So today we're going to look at the coefficient of determination. So it's, just be careful, this is R squared. So if you remember, R was actually correlation coefficient. So note there's a difference there. So sometimes they're not going to say find the R squared, they'll say find the coefficient of determination. So just be wary. They look similar, but there's a different word there, see? So be careful. So the R squared is what we're going to look at today. So if you remember back to what we did the other day, we had a scatter plot and we ended up, I said to you, we found this R value. So what happens with the R value, they take the line of best fit, the calculator works it out, and they're doing that by taking into account all the little distances between the dots and the line of best fit and things like that. So they get this R value. Now we're going to look at the R squared value, and it tells you the degree, and here's what this R squared means. So it's actually found in the same spot where you found the R value. So remember you do that lin reg A plus B, and you'll see the R value in the calculator, and you'll actually see, I think R squared comes first and then the R. So we'll have a look. I'll show you in a minute on the calculator. But what does the R squared tell you? It tells you the degree of which one variable can be predicted from the another, but it's only if there's a linear relationship. So like the R value, we're going to decide that, yeah, we think it's linear, and then we can say, all right, use the R squared, and we'll predict what we think can happen. So you obviously find the R squared is found by squaring the R value. Okay, so if you think about it, it doesn't matter if you have a negative R value. If you square a negative value, you get a positive, don't you? Yes, so the coefficient of determination, and you might want to write that, is always positive, yeah? So it's always a positive number, because even if you had a negative, so say for example you had R equals negative 0.8, if you go negative 0.8 squared, you'll get 0.64, okay? So it's always going to be a positive. So now we're going to work out, so with the R squared value, it's this one statement that they want you to tell about it, and you'll see, and that's why it's boxed here, because you need to write it like this, and you need to look out for this wording. You'll know it's the R squared they're talking about when you see it. So we've got a little example here. We've got the correlation between the weight and height is 0.8. So here they gave you the R value. So for us, we'd say, because they gave me that R, I know that this is obviously, they're assuming it's linear relationship, and it's a strong positive relationship, because I know from 0.8's in the strong category. So then they said the coefficient of determination, so that's the R squared, so I square it and I get 0.64. And then what they often ask you to do is you times it by 100. So we times 0.64 by 100 and we get this number 64%. So what you could do now, because this was the correlation between height and weight, I can now make this statement. So I can say the coefficient of determination tells us that. Now, see in the yellow, I put it in the yellow, that's what you, that's what, when it's in yellow, it means you have to put something in there. All right, so everything else you can copy straight. Now we've got to put it. So for our example, it says, so it's telling me here to put the R squared times 100. So I'd write 64%. Okay, so the coefficient in this example tells us that 64% of the variation. Now I have to change this. No, I don't want to write the words response variable. I want to write what it actually is. And for this scenario, this was your response and this was your explanatory. So I would write in there, 64% of the variation in weight is explained by the variation in height. Okay, We're just saying as we change people's height, the weight changes, and we're saying the variance is 64%. So then we might say there's 36% of other things that are affecting the change as well. Okay, so here I've written it out to show you how that would look. All right, so you must write this. You're not going to get marks. It's so easy. Just fill in the blanks and write that, yeah? So we've got an example question here. Sorry, it's pretty small. I'm just going to zoom in a bit. Okay, so thus the relationship has significance. So you got to say if it has a certain amount of percentage. So 64 is a high percentage. So we're going to say yes, there's some type of relationship between height and weight. If you found an R squared to be under 30%, whatever you're investigating has probably got nothing to do with each other. So an example for that might be, I don't know. So number of times you drove the car and your height, got nothing to do with each other. You could actually make a scatter plot out of that, yeah, because you could get all that data, but it might come out with because it's got nothing to do with it, has it, yeah? All right, so that's what it means. So anything under 30, you're really saying it's not worth it. Okay, so here I'm looking at this one. The scatter plot below displays the resting pulse rate in beats per minute and the time spent exercising in hours of 16 students. So see how it says 16 students? There is 16 dots there, yeah, because we got 2 pieces of information from all of them. All right, the least squares line is fitted. We're going to learn about that, but the line of best fit is called the least squares line. And they've given us this. So we can see too that this is our RV and this is our EV. Now, they've said the coefficient of determination. So when I read these things, I put R squared above it, so I'm not stuffing it up. They're giving me R squared there. Now they want me to find the R. So if you're given R squared equals 0.8339, a way you can find R is actually you do the reverse, yeah, the square root. So if you do the square root, you put 8.339. You can do that on your calculator, but your calculator does not tell you, and it should. Remember that you could have a plus or minus answer, couldn't you? Remember all those methods, kids? Yes. And I just said before, R can be negative. R squared's always going to be positive. So you do the square root of that, and I'm going to quickly do. So it's plus or minus 0.913. Okay. So you have to always remember you have a choice. You have to pick whether it's negative or positive. And you are told somehow which one it is. I know that the answer is negative, and I know that. Why do I know that? What am I looking at? Good. We're looking at the graph, and because that graph is negative, that R value had to be negative. And that's what they're doing. They must give you some information that makes you know that it's plus or minus. So we worked out that one's minus, so that's the answer. When you do it in your calculator, it'll just give you the positive answer. So then if you look at this next question, down below, it says the coefficient of determination, or R squared. So they've given it as R squared, which is nice. They were nice this time. Now, they're saying 12.5 of the variation in life expectancy is not explained. See how they say not explained? So remember our little blurb here that we got before, it tells me how to write if it is explained. So what I'm going to say here is when this tells me that 87.5% of the variation in life expectancy is explained by variation in HDI, whatever it was. Okay, so that tells me that, but what's not explained is all the rest of it, yeah? So when we have, so this not explained is 100% minus what the R squared was 87.5. So I'm just showing you, they could give a question like that where they give the not the R squared value. So just be aware of that. That was a multi-choice. I've just chucked the section in to show you that, to be careful of that, reading that. All right, so if I go to the next page, we've got another exam question. So use the following information for questions 9 and 10. Good, we'll do that. Oh, okay, so this information is used for the following. So the least squares line, so that's like we'll learn in a minute, is a line of best fit, is used to model the relationship between average monthly temperature and the latitude recorded at 7 different weather stations. Okay. The equation is, and here we go. So later you're going to learn this is our equation. So normally that's the y, which we call RV. And this is our A, which is like my y-intercept, and mine, this one plus B, which is like the gradient, and EV. Okay? Not too important here, but it's there. We'll learn that in a minute. So when the numbers in this equation are correctly rounded, oh good, so we've got some rounding practice, to 3 significant figures, the equation will be, so let's go look, this would be 1, 2, 3, so that means that's got to go up, so that's going to be, we did this one the other day, didn't we? 43, so 43 is, I'm going to get rid of anything that doesn't say 43.0. There you go. And then the next one, start counting. 1, 2, 3 at the non-zeros. So that one will stay as it is. So this is that answer. Okay, we've done that. But the coefficient in the next question, the coefficient of determination was calculated and it was this. So this is R squared. Now they want you to find R. So R is going to equal plus or minus the square root of this number. 743. So let's someone do that one. Okay, I get that to be plus or minus 0.94538 or whatever. Okay, so remember, like I said before, I have to decide if it's plus or minus. They've given me some information. What do you think it is? Can you see it? Anyone see? Yes, good. Because up here, this is like the gradient. The B value is like the gradient. And can we see that it's negative? So we know that this one has to be, if it's a negative, it means like the line of best fit went like that. So therefore, we've got a negative gradient. So you go and find the negative R1, and which is A. So see how they give both? They've got a positive and the negative value, so they're going to catch you if you're rushing and you don't do it properly, okay?